So welcome to section 8.2. This is where we put everything together. We are looking at claims that deal with percentages or proportions. And so as the first example, we'll look at number 12, which is written here. And you can see that the 100 M&M candies were looked at and 27% of them in our study were blue. Looking at the packaging, it says that they claim that the blue percentage is equal to 24, and so we're going to test that claim. And so we're testing the company's claim. So the claim that's being tested is the claim that the percentage of blue M&Ms is equal to 24%. Make sure all your percentages are written as decimal number equivalents so that we can actually run them in a calculator. The next thing that we should do is step number 2. So step number 1 was to write the claim in symbols. Step number 2 is to identify the null hypothesis. And the null hypothesis always has the equal to sign and always involves a number in the claim. And the alternate hypothesis, which always involves the thing that we're making a claim about, in this case a percentage, the number in the claim, and then it's going to have an inequality symbol. And so typically it's the claim, but this time it can't be because the claim is a direct equality, so it's going to be the opposite, and it's a not equal to. So those are the first two steps. Then we're going to calculate the test statistic. So what we're going to do next is run the test statistic. And what the test statistic is measuring is the distance what we saw in the sample and how far that is away from what the value is in the claim. And so as we run this guy, our test statistic is going to be a z value. And so let me write that z first. And it's going to have the formula p hat minus p all over the square root of pq all over n. We got to practice with this a little bit in 8.1 and in other videos. So let's plug in some numbers. P hat, the percentage of blues in the sample, 27%. P is the 24% that's in the claim. P is the 24% that's in the claim. And then Q would be 1 minus P, and so Q would be 76%, right? And that's all over the number of candies that we looked at. And so that's what we have, is that setup right there. And so now we're going to run that in our calculator by typing in 0.27 minus 0.24. Make sure to hit equals. Divide that by the square root. And then just type in what you see. 0.24 times 0.76 divided by 100. And what we come up with is a z value of 0.702. So I'll put a 0, 0.702, so 0.70. Now what's awesome is they'll have that value reflected in the back of the book. As mentioned in the instructions for 8.2, they're also going to reflect the p-value, but you're going to ignore that because that's not the method that we're using. You know a lot about this z-value. That z-value is 0.7. That means that 27 is not very far away from 24%. It's only 7/10 of a percent, or 7/10 of a standard deviation away. That's not very far at all. Let's go get our critical value, which would be the next step. Now in this case, we have a not equal to null alternate hypothesis. And so what are we going to do? We're going to have a two-tailed test. Now we need to look and see what our significance level was. They're asking us to use 0.05. And so because there's two tails, we're going to put half of it in one tail and half of it in the other. We're going to go look that up, and we're going to get a negative 1.96 and 1.96 when we look that up in our charts. So our critical values is 1.96 and negative 1.96. So the last thing to do would be to compare and conclude, make a conclusion about the null hypothesis. It's actually the second to the last thing that we'll do. There's one more step. So now we're going to compare 0.70's as its test statistic to these z-values. And we're going to recognize that 0.70 is just to the right of center. But it's in this big, wide, open area in the middle. So because of that, we're going to fail to reject the null hypothesis. So that's the conclusion about the null hypothesis. Again, we'd only reject if we were more than 1.96 standard deviations away, but we're only 0.7, so we got to fail in that attempt. Because we fail, we're going to write this. Every time you fail to reject, you're going to say there is not sufficient evidence to warrant rejection of the claim that 24% of the candies are blue. You must write this last sentence. I can't give you full credit without it. It'll be modeled in every single answer in the back of the book, and therefore we need to do that as well. You'll watch them use terminology that's very, very similar each time, but if we fail to reject, there's not sufficient evidence to warrant rejection of the claim. Now, the claim in this case was our null hypothesis, so that's why they're wording it that way. But we don't have enough information to reject that, so it could still be 24. Looking at those 100 candies and seeing them come in at only 27, well, not only 27%, but seeing them come in at 27% was not enough of a distance away from the 24% for us to disbelieve that it could actually be 24% if we looked at all the candies. And so that's a full problem. You wouldn't have to do much on your exam other than this. I can see what your test statistic is. I can definitely see the critical values. I can definitely see the rejection of the failure to rejection of the null hypothesis and the end statement. So that would be a perfect way to answer this type of question on the exam. So we'll look at other examples from this section as well.